Hello everyone, welcome to the Abridged Physics class for the section 405 for the chemistry student. Let me introduce myself. I am your teacher for the first part until the midterm exam. My name is Phakpoom Ruenchan. I'm from the physics department. My office is just room number 451 at the 45-year Science building, the one that have 7-Eleven downstairs. I hope you already visited it for lunch or something. Okay, for the beginning, I would like you guys to join the Google class, which you should check your email because I already invited you via the email.ku.th, and I will post my teaching materials and video sometime in the Google class, as well as we will have the homework in there, so please join it as soon as possible. Okay, for today I will introduce you how to learn the physics in my part. Okay, for the book I use is Physics for Scientists and Engineers by Solvay and Javid, and of course I will use the another textbook, for example Holiday, and some of the standard textbooks that you can download it for free. Yeah, there is one. I will post it later. Okay, for my part is 50%, so we will have attendance plus homework 10% and exam 40% here. However, this grading it can be vary from 10 to 20%. Is up to your performance, and exam as well is not exactly 40%, so it can be 30 to 40%. So I will decide it later when you have to judge your grade around the end of the semester. Okay, so okay, before we start, let me show you the course syllabus, which I already post in the Google class. So in this class we have 3 credits, so we will have the in-class teaching and studying at 1 p.m. to around 3:30 or almost 4 p.m. every Wednesdays. Okay, every Wednesdays. But for today's video, because we have the national holiday 12 August, so I make this video for you to learn online. Okay, for the first part we will try to understand the fundamental idea of the physics, focusing on the mechanics. The mechanics is kinematics. Here is the kinematics and motion along the straight line, motion in 2 dimensions, Newtonian motion laws or Newtonian laws of motion, work and energy, momentum and impulse. This is for my part, and if times allow, I will cover some of thermodynamics. Yeah, but most of time the time does not allow us, so usually I skip it. Okay, and for the second part it will be taught by another professor, Professor Vachari Ratanasakuntong. She will teach you about wave, sound, electrostatic, electrical current, magnetism, and electromagnetic wave. Okay. Okay, and This is a textbook, okay, and this is the class schedule for my part. So if we follow this part, we will cover the momentum around before the midterm exam, which will be around 26 September to 4th October 2020. Okay, and look back to this slide. I will post it later. Okay, so the physics, usually we start with the measurement. It means we need some instrument to measure the physical quantity. So if quantities, for example, length, mass, or time. Yeah, for example, if we have one object, for example this object, and I want to measure its length, we need ruler, right? We need ruler to measure its length. What is the width, the height, and the thickness. Okay, so we need a ruler or something else. So you might learn about how to measure the length of the object in your laboratory. Yeah, you will use ruler or vernier or even the micrometer. Okay, how about the mass? The mass, we can use the scale, can be electronic scale or the mechanical scale, for example the spring scale, to measure the mass. And time we use clock, right? Clock or watch or stopping watch, that you have your watch can be smart watch or mechanical watch. Okay, however, if you measure something, you need to specify the unit. For example, if I ask you what is the length of this object, if you tell me, oh, it's 5.2 what? It should be 5.2 centimeters. Okay, 5.2 centimeters or 5.2 inches or 5.2 meters. So we need the unit, otherwise the number we got from the measurement is meaningless. Okay, so we need the unit. In this case, the length, we have the unit in meter. This is the unit in the SI, is affiliated from the System International. Yeah, so we have kind of international committee to make our life easier by setting the unit, the standard unit. So we have the unit for the length is meter, and the unit for the mass is kilogram. Okay, the mass is kilogram, and time is second. Okay, time is second. These are the standard unit in the SI system for the length, mass, and time. Okay, length, mass, and time. Okay, so the problem is, how do we define the length, the mass, and the time? Okay, how do we define it? For 1 meter, okay, so 1 meter, this definition is a kind of a current definition, but in the past, if you Google or read some textbook, you will find it in the past. People in the ancient time, they might use the kind of stone, maybe like this. Yeah, and they measure it, and they say, oh, this stone, the length of this stone is 1 meter, and somehow the stone can be decayed, right? It can be decayed or have some corrosion when times go by. So the length might not be certain, so it might be a little bit shorter when the times go by, like 10 years or 100 years. So it's not good to define the length. So now because we know that speed of light that shown by Einstein, that the speed of light is the constant, is one of the constant of the universe. So we can define 1 meter is the distance traveled by the light in vacuum during the time of this big number. Okay, this big number. So this define the length of 1 meter. Okay. How about the mass? The 1 kilogram mass here, the 1 kilogram mass is defined by the mass of the specific object made from platinum and iridium alloy. It's a two type of metals mixed together, so we call it alloy. And this cylinder, we call it platinum iridium alloy cylinder. We show in this figure. This is the alloy I'm talking about. Okay, and somehow the standard of 1 kilogram is redefined just in the last year 2019. So I will show you in the next page. So how do we redefine it? Okay, but we just use this definition for the 1 kilogram, maybe I think for 60 or 80 years, and we just change it recently. Okay, for the 1 second, for 1 second, how do we define? We do not define by using the stopping watch in your smartphone or in your smartwatch, but we define by using the vibration of the cesium-133 atoms. So because the cesium-133 atoms, this isotope is very stable, and if we can count the vibration of the radiation, so it will be very certain that 1 second is equal to the period of the vibration of this cesium-133 atom, this big number. So this define the 1 second. Okay, this define 1 second. Okay, but however, just last year the System International Committee redefined the definition of 1 kilogram. Okay, of 1 kilogram. For the second, we use the same as the previous one, as the previous definition. For the meters, it's the same as the previous one. Okay, only the some addition of the strict definition of second propagate to the meter. Okay, but the one that changed a lot is 1 kilogram. We do not use the platinum iridium alloy anymore, but we use the Planck constant H, Planck constant H to be used to define 1 kilogram, because the Planck constant, you know, Planck constant is in the physics we have some kind of equation like E, the energy of the photon, equal n h bar omega, and h bar, this h bar is h over 2 pi. H is a Planck constant. It's one of the universal constant that will be never change of the universe. Okay, if you watch kind of a series, do you watch Stranger Things, maybe season 3? So one of the character, the girlfriend of chubby boy, she very smart. She used the Planck constant to be the password for for some of her treasure. box, so she used that the Planck constant as the password. Okay, so it's a kind of a constant of the universe, so it will be never change. Okay. Okay, and this page will show you. Okay, for this slide I will talk about the prefix that we usually use for describe the length or mass or time. So usually we will use this kind of prefix. For example, 10 to something like this. So the one that you might be familiar is like a nanotechnology. So what is a nano? The nano, that means something very very small, right? And the one you know is maybe molecule or atom. So it's in the scale of nanometers. What is nano? Nano is a 10 to -9. So it's we call a nano something. For example, nanometer, something like that. Sorry, something like that. So we call it nano. Okay, we call it nano. Or pico. Pico is a 10 to -12 or -12, up to you. Okay, or centi, we have a centimeter, right? We have centimeter. So it's a so it's a 10 to -2. This is a very very small thing. So because in the physics or in the chemistry we have a very very small object. For example, atoms. Okay, we have molecule, right? Molecule, and smaller than molecule are atoms, and smaller than atom, what inside atom, you know? Inside atoms are electron, proton, and neutron. Okay, what about smaller than electron? Is there anything smaller than electron or proton or neutron? The answer is yes. We have quark, right? We have quark. We have maybe 12 or 24 type of quarks. I don't remember. I'm not sure. Okay, and they're very very smaller than neutron or electron or proton. So we have until like a septo or yocto. On the other hand, we have something that very big too. So we have like if you want to describe the mass of an elephant, you use maybe the kilo. The mass of yourself don't need to be elephant. Okay, kilo is a 10 to the third. Okay, so it's a kilo or kilogram, kilometer, kilowatt, kilo something. And we have a mega, or even bigger, giga. So you might know megabyte, gigabyte. Yeah, but that is not exactly equal to the physics definition. Yeah, and we might study something very big like in galaxy or kind of intergalactic. So we have to use very very large number or zeta or iota. Okay, so this is kind of the prefix that you need to know about it too. Okay, yeah, in the physics, if we want to understand something, so we need to look into a very very small scale. For example, if we look at gold, yeah, this is gold, look very beautiful, right? Gold look very shiny, yellow. Yeah, everyone want gold. So what are gold that we see here composed of? it composed of piece of a gold atom. Gold atoms in the the element table is called AU, right? AU, the symbol for gold, AU. So it composed of the many of gold atom. Okay, gold atom is here, and if you look at gold atom here, like this is, for example, this is gold atom. So the inside of gold atom, it composed of nucleus. Yeah, nucleus here, nucleus, and you might think, oh, there are electrons around, right? So the electrons around the nucleus, yeah, is a one model to describe atom, maybe introduced by John Dalton. Okay, I'm not so sure, but maybe John Dalton. But later, some physicists and chemists, they help together to redefine or redescribe how atoms look like. So now we know that electron is not orbiting around the nucleus. It's like we have the cloud of possibility of finding electron around the nucleus, or the wave function of the electron. Okay, if we look at the nucleus of the gold atom, in the nucleus is composed of protons here, protons and neutron. Okay, the protons are orange one here. This is proton, and the gray one are neutron. The gray one is here, the gray one. Okay, so as I mentioned before, now the physicists know that inside proton or inside neutron, they composed by quarks. Yeah, it composed by quarks. So we have 3 quarks in one of the particle, right? 3 quarks. U maybe from up, yeah, up, down. So it composed the particle. Okay, so next, in the physics, we do not have only the fundamental quantity, we also have kind of relative quantity. For example, we have area, yeah, for example, area or volume, right? Area, volume, speed, or acceleration. Okay, let's talking about the area first. The area you familiar with it, right? Like the area of your house, or the area of an object, like small object like this. You have the area. The unit of the area is maybe meter square. Okay, the meter square, because when you try to calculate the area of one object, for example, this object, right? And you want to find the area here. And you might be able to measure. For example, this is 2 meter this side, and this is 3 meter this size, right? And then if you want to find the area equal length times width, for example. So here is a 3 meter times 2 meter, so it will be equal 6 meter square. Okay, because it's meter times meter, so it's a meter square. So the dimension of the area is we use L for length, so it's L square, but in the SI unit it's a meter square. Okay, so if we do the same thing for the volume, for the volume we have something maybe like this, like volume. Okay, and you have to calculate the volume. The volume here is maybe 3 meter here, 2 meter here, and 1 meter here. So it's length times width times maybe thickness, so it's equal 3 meters. Maybe it's equal 3 meter times 2 meters and times 1 meter. So you can see here the unit will be meter cubic. Okay, so the dimension is L square, L cubic, and the SI unit is a meter square, meter cubic. Okay, another example is the speed. The speed is some quantity that you want to measure how fast of an object. For example, a car. Okay, so we have to measure as a function of time, right? As a function, not a function of time, but like how far an object can go per the unit time, per the unit length of time. So it's a meter per second. So when we talking about the dimension, is a L over T, the capital T denoted for time. Okay, and acceleration is L per T square. Okay, so we use the bracket here to denote the dimensions. For example, the dimension of the speed. The dimension of the speed is L over T. Okay, L over T. The dimension of the speed. Okay. So here, if we want to understand the dimension, so we look at example. Okay, so follow me. So in this example we have to show that the expression v equal at. Is a speed equal acceleration time, right? So where we represent speed a acceleration and t an instant of time is dimensionally correct. So how do we show it? Okay, so at the beginning we know that the dimension of the speed we write it like this. Okay, in the bracket is the dimension of v will be equal L over T. So we have to prove. That the dimension of v equal at is L over T. Okay, so we start from this. Okay, so we write down the bracket of v, so should be equal the bracket of a time the bracket, so dimension, the bracket mean dimension. Okay, dimension of a time dimension of t time. So it will be L over T square, right? This is acceleration. And time T. Okay, so now if we do some math, we will get that, oh, the dimension of V is L over T. So we can conclude that the V equal AT is dimension, oh sorry, I think I spelled wrong, dimensionally correct. Wait, sorry. Dimensionally correct. Okay. So next, the thing that you should know in the fundamental of the physics before you start the chapter 1 is the conversion of the unit. The conversion of the unit is like if you live in the states, like in USA, people use mile for the length, like 1 mile. But in Thailand, we use meter or kilometer. So you might need to know how to convert. For example, 1 mile is equal to 1,609 meter or 1.609 kilometer. Okay, and 1 meter will be 39.37 inch for example. Okay, so this is a kind of the unit conversion. So let's see an example about the car. So what is this car? It's really beautiful. I just find this picture from internet, so I think it's a car. Is this Ferrari? Oh, Ferrari. Okay, we should not talk about the Ferrari at the moment. Okay, so the question is that if a car is traveling at the speed of 38 meters per second, look quite fast. Is the driver exceeding the speed limit of 75.0 miles per hour? This is the speed limit in the US. Okay, maybe in the interstate, in the highway, I guess. Okay, how do we start? So we might have to use the table from the last page to convert meter per second to mile per hour. Okay, let's start. So we know, right? We know that V equal 38.0 meter per second. So first we should convert it by using this method. So I usually use my, I do this, my times my and times hour over hour. So this, if we multiply this unit, right, mile per mile dot hour per hour, nothing change, right? Nothing change. So the number should be the same. I mean the 38.0, but we have to convert, for example, like this. So we need mile per hour, right? We need mile, maybe mile per hour. So we have to convert hour and mile to become meter and second. Okay, let's see. So we will get 38.0 times meter. Okay, we convert mile to meter first. We convert hour here, hour to become second, so it's 60 times 60, right? 60 times 60 second, and mile to become meter. My to become meter is from the last page, so it's this number. So it's this number. So it will be 1609. 1609 times meter. we have meter per second, right? So meter second cancel with second, so we will leave my per hour, right? So we leave my per hour. So if we calculate, okay, I hope you are not confusing, right? Because I keep this my per hour at the beginning, so it become here, but for meter per second here is here, right? And then these I got it from converting the unit. Okay, so once we calculate this number, so we will get around 85, right? If you do not trust me, you can calculate it by yourself. You will get 85 mile per hour. So is the driver exceeding the speed limit? Yes. So we can answer that the driver is exceeding the speed limit, which is not good at all. If you drive a car, you should obey the law by not exceeding the speed limit. Okay, so everyone should believe me, and it will be good for yourself. Okay, but this is in the US. So how about if this driver drive this car with the same speed in Thailand? Is he exceeding the speed limit of Thailand? Okay, another question that is this driver exceeding the speed limit of Thailand? Okay, the speed limit of Thailand, I will talk about the speed limit in the how to call it, in ต่างจังหวัด or maybe in interstate. So we will use 110 kilometer per hour, but if you drive in the city, it will be 80 kilometer per hour. Okay, so please remember. So now we have to convert the unit again using this answer. So how to convert the 85 mile per hour to become kilometer per hour? This is quite easy. Okay, quite easy. Follow me. So we got V equal 85 mile per hour, right? And then we use that table again. So V times 1.609, because 1 mile equal 1.609 kilometer, so we just use this from mile to kilometer, and we keep an hour. So if you calculate this number, you will get V equal, okay, should be exceed, right? 137 kilometer per hour. So we can conclude that, oh, he also exceed the speed limit of Thailand. So not good. Do not do it. Okay, do not do it. Okay, please believe me. Okay, I hope you get something from my preliminary teaching for the chapter 0, and for the next week I hope we will see you in the real class. Yeah, I will post the room number again. I don't remember now, but it will be in the chemistry building on the first floor. Okay, so that's all for now. Thank you for watching. See you.